When you're new to Linux, it's easy to think of a computer as doing one thing at a time, because that's how it feels from the outside when you click an app or open a file. In reality, Linux is always running many processes at once, and most performance problems, crashes, and strange behaviors can be explained by what those processes are doing right now. The Linux Plus exam leans on this topic because it tests whether you can observe a system calmly and form a first, reasonable hypothesis instead of guessing. The tools for that observation can look intimidating at first, but they become straightforward once you treat them as different windows into the same underlying truth. Some views are quick snapshots, some are live dashboards, and some are deep details exposed by the kernel itself. The key skill is knowing what to look for first, because the first few seconds of process investigation often decide whether you solve the problem efficiently or wander around confused. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A process is simply a running instance of a program, and Linux assigns each process a process identifier, PID, so it can track and manage it. That PID is how the kernel knows which process is requesting access to a file, which process should receive a signal, or which process should be scheduled on the processor next. When you look at process information, you are usually trying to answer one of a handful of questions, even if the situation feels messy. You might be asking which process is consuming the most central processing unit, CPU, time, which process is using the most random access memory, RAM, whether a process is stuck, or whether the process you expected to be running is missing. Those questions sound simple, but beginners often look at a screen full of numbers and don't know which ones matter. A good process reading habit starts by choosing a single question and then finding the data fields that answer it. Once you can do that, process tools stop feeling like noise and start feeling like evidence. The tool PS is best understood as a snapshot view, meaning it shows you a picture of process state at the moment you ask. That is valuable because snapshots are stable, readable, and easy to compare, especially when you want to confirm whether something exists and what its basic attributes are. With PS thinking, you are typically confirming identity and context, which user owns the process, what command started it, and what PID is associated with it. For beginners, PS is often the first step when you have a specific name in mind, such as a service you believe should be running, because it can quickly confirm whether it is present. It is also useful when you want to see the relationship between processes, like parent and child behavior, because processes often spawn other processes, and those relationships can explain odd symptoms. Linux Plus questions often describe a process by name or by role, and then ask you to identify or reason about it. And PS-style thinking is how you translate that narrative into concrete process reality. The tool top is best understood as a live dashboard, meaning it updates continuously and shows how resource usage changes over time. This matters because many problems are not about a process existing, but about a process changing, spiking, or slowly consuming resources until the system becomes unstable. Top is often where beginners first see that CPU usage can surge, then drop, then surge again, and that pattern is a clue about workload, scheduling, or contention. The key benefit of a live view is that it helps you distinguish a constant problem from a bursty one, and it helps you see whether a suspect process is consistently dominant or only briefly visible. Another benefit is that top often reveals system-wide pressure, such as high overall load, which can mean the system is trying to do more work than it can complete promptly. Linux Plus questions that mention slowness, lag, or a system that becomes unresponsive often want you to think in terms of live resource monitoring, not static snapshots. If you treat top as a real-time story rather than a single number, you'll interpret symptoms more accurately. The tool top is best understood as a more human-friendly live dashboard that emphasizes readability and interaction, but the mental model is still the same. It is a living view of processes competing for resources. For beginners, top can be easier to parse because it often presents information in a clearer, more navigable way, making it simpler to focus on the processes that matter. The exam is not typically testing whether you prefer one interface over another, but it does test whether you understand the kinds of conclusions a live process view supports. A live view lets you notice whether multiple processes share a common name, which can be normal for some services and suspicious for others. It also lets you see if a process is changing state, such as repeatedly restarting or briefly appearing and disappearing, which can hint at crashes or misconfiguration. Most importantly, live views teach you that system performance is not a single metric, because a process can consume high CPU without consuming much RAM, or consume high RAM while barely using CPU. That multidimensional reality is what your eyes need to learn. The /proc file system is where process reality becomes deeper because it exposes process and kernel information as files you can read, which means the system is showing you its internal bookkeeping directly. For beginners, it helps to think of /proc as a live interface to the kernel's view of the world, not a directory of normal files stored on disk. Many tools, including PS and top-style dashboards, are ultimately pulling their information from the same underlying kernel sources that /proc makes visible. The reason /proc matters for Linux Plus is not because you need to memorize every file there, but because it explains why process information can be read in a consistent, structured way. If you ever wonder where the tools are getting their data, /proc is a major part of the answer. It also helps you understand that process state is not a mystery, because the kernel tracks it explicitly. Identity, memory maps, open file descriptors, and many other details exist as inspectable facts. When you can connect high-level tools to /proc as the source of truth, you trust your observations more and you troubleshoot with less superstition. Now let's focus on what to look for first, because beginners often stare at the wrong metric and miss the real story. The first thing to decide is whether the problem feels like a responsiveness problem, a memory pressure problem, or a missing process problem. If the system is slow and fans are loud, your first suspicion might be high CPU consumption, which you can see in a live dashboard by identifying who is consistently at the top of the list. If the system is sluggish in a way that feels like it is constantly waiting, your suspicion might be heavy disk or input-output I/O activity rather than pure CPU, which can still show up indirectly as processes that spend time waiting instead of executing. If a service is simply not doing its job, your first step might be to confirm whether the expected process exists at all and whether it is owned by the expected user. This decision-first habit prevents you from treating the process view like a scoreboard and instead treating it like a diagnostic instrument. Linux Plus scenarios often include language that hints at which category you are in, and the best answers reflect that first categorization. After you have a category, the next thing to notice is whether the problem is about one process or about many processes competing. A single runaway process is often the easiest case because it dominates one resource and becomes visually obvious in a live view. Competition problems are subtler because no single process looks outrageous, yet the system as a whole feels overloaded, which can happen when many processes each consume a moderate amount of CPU or I/O. In those cases, the clue is often the overall level of activity rather than one villain, and the right question becomes whether the machine has enough capacity for what it is being asked to do. Beginners sometimes misinterpret competition as a mysterious slowdown because they expect one culprit, but Linux often slows down simply because there are more runnable tasks than available execution time. This is where understanding that the scheduler is sharing resources becomes important, because the system is not failing, it is managing contention. Linux Plus questions may describe high load or many active tasks, and the intended reasoning is that the system is overcommit, not broken. Your first glance should therefore include both the top consumers and the bigger pattern. Another early check that matters is identifying whether a process is running under the identity you expect, because ownership often explains behavior and access errors. If a service is running as a constrained identity, it may be unable to read a file or bind to a port due to permissions, and the process view can reveal that mismatch quickly. Beginners sometimes focus on the process name and miss that the user context is wrong, which leads them to chase the wrong explanation. A process can also be started from the wrong location or with the wrong command line options. And while we are not doing command-heavy work here, Conceptually, you should understand that the exact command that launched a process is part of its identity story. This is why PS-style snapshots are so useful early in troubleshooting, because they show the process lineage and ownership without the distraction of constantly changing numbers. Linux Plus questions often encode this as a scenario where a service exists but behaves incorrectly, and the correct reasoning is to inspect the process context rather than assuming the application itself is defective. If you train yourself to ask who owns this process and how it started, you catch many issues early. Memory interpretation is another place beginners stumble, because our AM usage is not as simple as a single number being high. Linux uses memory aggressively for caching to improve performance, which means a system can appear to use a lot of memory while still being healthy. The key beginner skill is distinguishing a healthy use of memory for caching from a situation where processes are consuming memory in a way that leaves too little for the system to operate smoothly. When memory pressure becomes real, you often see symptoms like applications stalling, the system taking a long time to respond, and processes being forced to wait on slow storage because memory is not available for active work. Live tools can show which processes are large consumers, but your interpretation should include whether memory usage is stable or steadily growing over time. A steady climb can hint at a leak-like pattern, where a process consumes more and more memory and never releases it, eventually causing broader instability. Linux Plus questions may describe gradual degradation rather than sudden failure, and a memory growth story is a strong fit for that pattern. The first thing to look for is not just who is large, but who is trending. Process state is another crucial piece of reality that helps you avoid incorrect conclusions, because a process can exist while being unable to make progress. A running-looking process might actually be waiting for something, such as I/O completion, a lock, or another resource, and that waiting can explain why work is not being done even though the process is present. Beginners sometimes assume that if a process exists, it must be functioning, but the kernel tracks whether it is runnable, sleeping, or blocked in a way that reflects what it can actually do next. A process that is blocked on I/O may show low CPU usage yet still be the cause of user-visible slowness, because users are waiting for that I/O to complete. A process that is repeatedly waking and sleeping might indicate it is handling many small events, which could be normal or could reflect a misbehaving loop. While you don't need to memorize every state label, you should keep the conceptual idea that existence is not the same as progress. Linux Plus questions that mention a service that appears running but is unresponsive often want you to consider blocked or stuck states rather than assuming the process is fine. Your first inspection should therefore include whether the process is actively doing work or merely present. The /proc perspective helps here because it reinforces that processes have many attributes that live beyond what a single dashboard column shows. Even without diving into every detail, you should know that a process has open file descriptors, which represent files, sockets, and other resources it is using, and those resources can explain behavior. A process stuck might be stuck because a file it depends on is unavailable, or because a network socket is waiting, or because it is blocked on a device operation. Similarly, the command line and environment context associated with a process can clarify why it behaves differently than expected, because environment differences can change which files are read or which libraries are used. Beginners often blame the tool output when the real issue is that they are not looking at enough of the process's context. The kernel's process records exist because the system needs them to operate, so they are consistent and detailed, and tools like PS and htop are simply presenting parts of that record. Linux Plus questions often reward the student who understands that deeper context exists and can be consulted conceptually. Your first goal is not to read everything, but to know that the process has a real, inspectable footprint. Another practical first-look habit is to check for the presence of many similar processes, because quantity patterns can reveal failure modes that one process view might hide. If you see a flood of short-lived processes, it can indicate a service repeatedly restarting, a misconfigured job spawning too often, or a loop that is creating new work faster than the system can handle. If you see many processes in a waiting state, it can suggest a shared bottleneck such as slow storage, where many tasks are stuck behind the same resource. If you see only a few processes, but the system is still slow, it can indicate that the bottleneck is not process count, but resource quality, such as slow I/O or insufficient memory bandwidth. Beginners often look for a single smoking gun and miss these pattern-based clues, but Linux systems frequently fail in patterns rather than in one dramatic event. Linux Plus questions sometimes include hints like repeated failures, constant restarts, or widespread sluggishness across unrelated applications, and those hints align with pattern recognition rather than single process blame. The first inspection should therefore include scanning for repetition and clustering, not just the top line. As you practice reading process reality, you should also keep a clear boundary between observation and action, because beginners sometimes jump from seeing a process to trying to stop it without understanding the impact. The exam is not asking you to be reckless. It is asking you to interpret what you see and decide what it implies. A process that uses high CPU might be malicious or broken, but it could also be doing legitimate work, like compressing data or compiling software, so context matters. A process that consumes memory might be leaking, but it might also be caching or holding a dataset that is genuinely required for performance. The right first move is to identify the process, understand what it belongs to, and then decide whether its behavior matches its role. This is where your earlier identity lessons connect, because a process owned by a service account has a different expected behavior than a process owned by a user at a terminal. Linux Plus scenarios often test whether you can avoid simplistic conclusions like high usage equals bad process, and instead reason about whether usage is expected for the described workload. The first look should inform a hypothesis, not trigger a panic response. By the end of this episode, you should be able to explain how PS, top, and /proc fit together as different views of the same kernel-managed truth. PS gives you stable snapshots that are excellent for confirming existence, ownership, and launch context, which makes it a strong early tool for identity-driven questions. Top give you live, changing views that reveal resource competition, spikes, and trends over time, which makes them ideal for diagnosing slowness and instability patterns. /proc represents the deeper source of process facts, exposing what the kernel knows about each process and explaining where higher-level tools get their information. Most importantly, you should have a first-look habit. Decide whether the symptom suggests CPU pressure, RAM pressure, I/O waiting, or missing processes. Then confirm whether the issue is one culprit or broad contention, and then validate process identity and state before drawing conclusions. When you can do that, process questions become solvable by reasoning rather than by memorization, and that is exactly the level of calm system understanding Linux Plus is trying to measure.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.